Right, now we're going to look at balancing equations. Here is a displacement equation of zinc reacting with silver nitrate to make zinc nitrate and silver. So in this reaction you'd actually see silver metal being produced. So, is it balanced? What do we do to check? We've got to check the number of each element on each side. So on this side we've got one zinc. On this side, let's imagine there's a dotted line between here. There's one zinc, we're fine. One silver, one silver. One nitrogen. Here, the two outside the brackets means there's two nitrogens and 6 oxygens. And here we've only got one nitrogen and 3 oxygens. So we've basically got one nitrate ion here and 2 nitrate ions here. So we need more of these. And we can't just change numbers down here because that changes the formula of silver nitrate and it would be silver nitrate anymore. So what we do, we put a 2 in front of all of that. That means we need double the amount of silver nitrate. So that now balances our nitrates because now we've got 2 of all this, so we've got 2 nitrogens and 2 times 3 is 6 oxygens. So we've got 2 times 3 is 6 oxygens, 2 times 1, 2 nitrogens. Okay? So our nitrates are now balanced. But we must check the rest of the formula as well. Still got one zinc, still got one zinc. We've now got 2 Ags, 2 silvers, and only 1 over here. So by balancing the nitrates, we now need to go and balance the silvers, and we do that by putting a big 2 here. Okay, so that is now balanced. Let's look at another example. Right, so again, let's check on what's on each side. 4 carbons, only 1 carbon, not balanced. 10 hydrogens, 2 hydrogens, not balanced. 2 oxygens, 3 oxygens, not balanced. So there's a lot of work to do here. This is a combustion reaction. We're burning butane and oxygen. In this type of reaction, I always find it's best to balance the carbons first. So we've got 4 carbons. We're going to need 4 carbons this side. We put a big number in front of the CO2. So that's now 4 carbons. And that's also changed the oxygens, but we'll come back at the end. Now let's look at the hydrogens. We've got 10 here, and only 2 here. So we need a big number that when it's in front, whatever, something times 2 has to equal 10. Okay? So 5 times 2 equals 10. So we have 10 hydrogens here, 10 hydrogens here. The hydrogens are now balanced. Now we're going to look at the oxygens. So, got 4 times 2 is 8 plus 5. Okay? So 4 times 2, 8 plus 5. So we've got 13. Yeah, 13 oxygens. Okay? So we need a number here, something times 2 equals 13. So my speedy mental arithmetic, I know it's 6 and a half. Okay? There's a point there. Some people don't like putting fractions down, that's fine. What you can do then is just double everything. So we could change that to a 2, that to 13, change that to an 8, and that to 10. Okay, so we've got 8 carbons, 8 carbons. 2 times 10 to 20 hydrogens, 10 times 2, 20 hydrogens. 13 times 2 is 26 oxygens, 16 plus 10, 26 oxygens. It doesn't matter what multiples you have as long as it balances. So I could double all those again, that would still be balanced, or I could halve them, it would still be balanced. Okay, as long as they're still in the same ratio.